Hello everyone. Now today let us discuss the questions based on acid-base or neutralization titration. First question, a solution whose concentration is known is referred to as primary standard, secondary standard, titrimetric solution or a standard solution. So the solution that we are using for calculating the concentration or identifying the concentration of the unknown solution, that is known as a standard solution, using which we can determine the concentration of the unknown solution. Second question, the solution which has been standardized is known as. Now for the titration we are taking a solution in a burette that we know is known as a known concentration solution, that we call it as a titrant, and in the flask, that is the solution whose concentration is to be determined, is known as titrate or analyte. So here the question is, the solution which has been standardized is known as a titrant, which is filled in the burette to estimate the volume and to determine the concentration of the analyte that we have taken in a conical flask. Next question. The solution with unknown concentration whose estimation is being carried out is known as. So this is the solution which we are taking in a conical flask, of which the concentration is to be determined. So that is known as titrate, titrant, basic solution or a primary solution. So we call this as a titrate or an analyte, whose concentration is to be determined using a titrant, that is a known concentrated solution taken in a burette. Next question. Which of the following is used as a primary standard in acid-base titration? HCl, acetic acid, succinic acid, sulfuric acid, H2SO4. Now a primary standard is the one that is pure, it is stable, and it is non-hygroscopic. So if we consider here HCl or acetic acid or H2SO4, its concentration depends on specific gravity. So it is not stable. It changes with conditions like temperature and others. So succinic acid here is used generally as a primary standard in case of acid-base titration. Next question. The point in the titration when amount of titrant and analyte is equivalent stoichiometrically is called blank. Endpoint, transition point, equivalence point, or neutralization point. So in a titration when both titrant and analyte are in equal proportion chemically, that is stoichiometrically both are equivalent, that is called as an equivalence point. Next question. Methyl orange gives blank color in acidic solution. So based on the pH range, each of the acid base indicator gives different color when it is added into an acidic solution or in basic solution. So methyl orange gives red color when it is added into an acidic solution, or in an acidic medium, methyl orange gives red color. In acid-base titration, pH range of phenolphthalein is, so based on the value of pKin value, that is an indicator constant value, plus or minus 1 is the range that we get for any indicator. So based on the pKin value, it is nearly about 8 to 10, that is the pH range found for phenolphthalein indicator. The pKin value found is near about 9. So the pH range of phenolphthalein is 8.2 to 10. These indicators give specific color in an acidic or basic solution based on its pH range. So if we see phenolphthalein, it is having a pH range of 8.2 to 10, that is it gives a change in the color of the solution in highly basic medium, and in the basic solution it gives pink color, whereas in an acidic solution it is colorless. Thymol blue it is having the pH range of 1.2 to 2.8. That means it is an acidic type of indicator which gives red color in acidic solution, whereas the color changes to yellow in a weak basic medium. As such, we say it is acidic medium because the range is 1.2 to 2.8. Methyl orange, it is having the pH range of 3.1 to 4.4, and it is giving same acidic color red and yellow in the basic solution. Same way methyl red, it is having slightly the change in the pH range, but it is towards the acidic side more. So below 4.4 it gives the change in the acidic solution as red color, and above 6, so in between it shows the change in the color. That is why we are using this methyl red indicator in the pH range. It is showing the color change in between 4.4 to 6. In the basic solution it shows yellow color. Now if we see bromothymol blue, the pH range is 6 to 7.6, and it shows yellow color in acidic solution, whereas in the basic solution it shows blue color. Phenol red, having pH range of 6.8 to 8, shows yellow color in acidic solution, whereas in the basic solution it shows a red color change. So this range and change in the color in the acidic and basic medium you can remember, so that it will be easy for the questions that are asked based on the color change or the range or the solution required which type of indicator: acidic or basic, strong acid, weak acid, strong base, weak base. Okay. Next question, if we see the indicator used in the titration of a strong acid and a weak base is phenolphthalein, thymol blue, methyl orange, or starch. So here the question is based on the type of indicator that is used for carrying out the titration, where we are taking strong acid and titrating it with a weak base. So we require a indicator that is having the pH range in the basic medium. So we can use methyl orange, which is having the range in the acidic as well as a basic. As we have seen, it is having 3.1 to 4.4 pH range. So it shows the change in the acidic medium, and then after weak base it can show below 7, so it is about above 4.4. So methyl orange can be used. We cannot use phenolphthalein or thymol blue. And starch is as such a type of redox indicator. Okay. Next question. The indicator used in the titration of a weak acid and a strong base is. So now for titration of a weak acid with a strong base, we require an indicator which is having the range above 7 or highly in the basic medium, because we are titrating it with a strong base. So after the end point it requires a color change in the basic solution, so it has to be above 10. So naturally, if we see the options phenolphthalein, thymol blue, methyl orange, and starch, so we know that phenolphthalein, which is having a range of 8.2 to 10, it can give a change in the acidic medium also, and the endpoint that is having a strong basic solution can also be seen by adding phenolphthalein in this type of a titration where weak acid has been titrated with a strong base solution. Neutralization curve can be expressed in the graph as pH versus pKa, pH versus volume of titrant, pH versus Ka, that is dissociation constant, or pKa versus volume of the titrant. So we know that it is an acid-base titration and we are measuring the pH of the solution and plotting a graph of pH versus the volume of the titrant added. Next question. The indicator with pKa value 9.2 shows color change in the range 8.2 to 10, 6.2 to 10.5, 7 to 9, or 9 to 11. So as we know that it shows the range for pH as the value plus or minus 1 of the pKin or pKa value which is given. That is, it is actually the indicator constant pKin value. It is 9.2 plus 1 minus 1. So it is actually in the range of 8 to 10. So this is an indicator range for phenolphthalein that we have taken. Next question. The given titration curve is obtained or it is expected when the titration is of a blank acid with a blank base. So in the titration curve, if we see, the pH shows a drastic change near the end point or the equivalence point. And secondly, initially the value of pH is very low, that indicates that it is a stronger acid in the beginning. And after the end point, the pH of the slope, it is above 7. The neutralization point, as we can see, it is near to 7, and above that it is because of a basic nature of the solution. So it is actually the titration of a strong acid with a strong base, where always we can find this sharp change in the pH value. So it is a titration of a strong acid with a strong base. Next question. The given titration curve is obtained or expected when the titration is of a blank acid with a blank base. So in this case, if we observe, the initial pH value is slightly above, that indicates that it is not that stronger acid. So it may be a weak acid. So there are two options: weak acid strong base and weak acid weak base. Now after that, if we move on further in the graph, it shows a slope which does not show a very much change in the pH value. So say for example, we are taking a weak acid, say acetic acid, with a strong base. So it forms a salt, that is CH3COONA, that is a basic salt is obtained along with water. So when it is a weak acid strong base or strong acid weak base titration, it does not form complete neutral salt. Here the solution obtained will be basic, and after that if we see, it shows a rise in the pH and it shows the constant value after the equivalence point, that may be because of a stronger base. So here, because it is showing a slope which is having a buffer solution, it does not show a drastic change in the pH value, whereas the equivalence point, it is observed at 8 pH, and after that it is the curve because of a strong base. So it is the titration curve of a weak acid versus the strong base. Next question. The equivalence point when a weak acid is titrated with a strong base has graphically pH around. So it is a titration of a weak acid against the strong base. So base is added from the burette, that is strong. So naturally the basic solution will be found at after the end point or at the equivalence point, it will become basic. So it will be pH will be greater than 7. Next question. Which of the following titration will have the equivalence point at pH more than 8? HCl and NaOH, acetic acid, ammonium hydroxide, acetic acid NaOH, or HCl ammonium hydroxide. So pH more than 8 means it is a strong base that is added, and it is given that pH is more than 8. So it has to be weak acid with a strong base, because if it is a strong acid versus strong base, the salt found is to be neutral. But here the equivalence point is having pH more than 8. So a basic solution is obtained, that is a buffer of this acetic acid, and NaOH is formed, that is CH3CO minus with Na. It gives the basic nature to the solution at the end point. Okay, these all are the questions. Happy learning. Thank you.